All right, so let's get started. So today I will talk about how Blackfire works under the hood. We are a sponsor of Laracon Europe Online, and yeah, feel free to drop by our booth if you have more questions following up on this session. We will also have more sessions throughout the 2 days. We will do demos at our booth. So yeah, I'm really happy to chat with anyone who has some questions. I'm Christophe Dujarric, and I'm the Chief Product Officer at Blackfire IO. You can find me on Twitter. You can find me on our site, on our support site. You can even ask me for my email address if you like in the chat later on. Throughout my session, I will refer to some of the documentation that is available on our site. And in doing so, I will use QR codes on the slides so that you can easily flash it and go find more information if that may be of any help. And my session today will go through what Blackfire is. So I will describe it shortly, as we will have more occasions to describe it in details in upcoming sessions. Still, some basics are important to understand exactly, how it works under the hood. You need to know what it does. And therefore, the next part of what it does is where can you use Blackfire in terms of development, production, and so on. That will help me introduce the Blackfire Stack. So the various components that come into play when you start profiling your code with Blackfire. That will lead to some considerations on confidentiality and privacy of your code and of your end user data, so including the impacts on GDPR. And finally, this also will help me give you a few tips and tricks to get up and running quickly with Blackfire. So first of all, Blackfire is a profiler. So it is a tool that helps a developer measure and understand how their code is consuming resources. When we talk about resources, we talk about time in general. When you want to optimize the performance of some code, it's because usually you will have some expectations for your end users, perceived performance, and this is always a matter of time. So I'm going to spare the usual statistics that you can get telling you that so many seconds are going to give you so much more money. The point here is really to say, okay, when time when your code is taking too long to load or to execute in general, what you can have a look at is really the PHP code at first. You can always look for front-end stuff, but the PHP code is very often a source of potential optimization. And a profiler is a tool that will let you browse through time and have a look at its various flavors. For instance, when we talk about it, we can talk about the wall time, which is the overall PHP execution time. We can talk about the input and output, which is the time that PHP has been waiting for, memory access, network, anything like this. Then there is CPU. That's the time where the CPU is actually executing the PHP code. CPU plus IO therefore give you wall time. Then there will be memory, network calls, and SQL queries. Overall, what's really important is to understand that Blackfire is kind of a stopwatch. So it's a tool that when PHP starts executing some code, click, you start measuring how long it's going to take. And once PHP stopped executing that code, click again, and there you get the full, the actual metric. What's cool actually about Blackfire is that it's not just from the beginning of PHP to the end of PHP, but that those measurements go in much more details down to the function call level. So at function call level, you will know how much each function has been consuming resources. And then you will be able to display that into, well, what we try to build as appealing and interactive graphs so that you can browse through the whole code execution and figure out exactly where are the performance bottlenecks. That is what Blackfire is, a profiler, and therefore it is also not yet an APM. A profiler, you can get such visualizations like on the left side of the screen. So with a call graph, again, function calls calling each other, and then Blackfire telling you how much each of them is responsible for the overall here time consumption. On the right-hand side, this is more the kind of visualization you can expect out of an APM. So an APM, application performance monitoring, is a tool that will actually monitor production sites, and usually the point is that the metrics that will be collected based upon real end user traffic. And that's one of the key differences between a profiler and an APM. A profiler is able to get really deep down into the code and how again it's consuming resources. An APM is more here to oversee what's going on in production, and therefore, in order to avoid having too much impact, which is called the overhead, in order to avoid slowing down the real end user traffic, it will not collect as much information as the profiler. So the point is really, if you want to really master how the performance of your application is going, you actually need both tools. You need a profiler that goes deep down into the code, and then you need a monitoring tool that will oversee everything, but then with higher level metrics. Indeed, and that is also something that you will see when I will describe the stack of Blackfire. When you profile, you do not profile end user traffic. The profiles that you generate will only be on requests that you generate only and solely for profiling purposes. And therefore, that's what makes it very safe to use Blackfire in production. You should use Blackfire in production, actually. This is why we built it. You should use it in production because profiling in production is profiling with the latest version of the code, and actually more than that, the actual code that your end users are facing. So if they're facing an issue, you should be able to reproduce it with measurements directly in production. That will enable you to identify the issues. Now, once you have done that, the cool part is that Blackfire is also built to be used in development, so that on your local development machine, you can have a copy of the code that is in production, reproduce the issue, and then whenever you will try to iterate and try to optimize your code, you can measure again the new version of the code and compare it versus the previous one. So by doing that in the same environment, you will have the stability of the machine's power, and therefore a relevant way of comparing the two profiling iterations. The values of time will not be bound to two machines that have different powers. And of course, now that you can profile in production and that you can profile in development, well, obviously, wherever you can deploy your code, you can profile it. And that's also what is very powerful about Blackfire, is that it can even be integrated into any testing strategy. Maybe just a simple deploy to staging where a product manager would just click around and figure out if the features are working, or a full-fledged continuous integration and continuous deployment pipeline. That's how the Blackfire stack looks. So all of the red squares here on the screen are the components of Blackfire. So on the right-hand side, you have the Blackfire servers. On the left-hand side, you have the companion, which is basically the developer interface, so the user interface elements that will enable you to start profiling your code with Blackfire. And then in the center, you have the probe and the agent. The probe is actually a PHP or Python for what it matters. It's a PHP extension, and it is the component that will actually capture all of the performance metrics from your code, all of the values of time and memory usage. Those values will then be compiled by the agent that will then upload it to our servers. As Blackfire is a SaaS service, you will always visualize your profiles via the Blackfire site. What's key here is that, of course, you need to have all of the 4 components fully working and fully connected. And that's also what I will develop further when it comes to the tips and tricks. But again, in terms of the entire workflow here of the stack, you can see here the workflow that is designed. So the first thing is that once you have installed Blackfire on your machines, on the machines where you want to profile your code, there will first be a security layer. So when you install those components, we will also be asking you some credentials. And anytime a user will try to profile an application on the machine where you have configured Blackfire, the first thing that we will check is that person authorized to actually start a profile? So that's the the principle of getting a signed request, so 1 and 2 here on the workflow. And once we have the signed request, we can create a profile, check the signature that we actually generated before. Is that the correct one? Is that signature allowed really to trigger the probe? And then send the profile information to the agent. At that point here, we have collected really all of the information we could, including function arguments, so that you could, for instance, have information on SQL queries. Once the profile is completed, yeah, okay, we just killed the process. Again, what's so important about this whole workflow here is that it really means that an end user will not trigger Blackfire. By default, this is not happening. It's really a developer who will say, okay, now I want to profile this specific part of the code. So it will send a request to the servers just for the profiling purpose, and then it will switch off. So end users will never be impacted. In terms of developer user interface, you can actually work with 3 different ways. You can work with a command line. So we have a Blackfire CLI with here, for instance, on the screen, a curl wrapper. So Blackfire curl plus the URL of the request that you want to profile with whatever header you want that will actually reproduce real context. That will work just fine. There is more advanced ways with a PHP SDK so that you can even instrument manually your code. So in the first case, we were talking about really purely automated instrumentation. The second part is manual instrumentation. This is probably where you should be careful indeed, because poor instrumentation in production could lead to actually having your users impacted by the Blackfire overhead. So yeah, please use that with caution. And the last is the most easy way to profile, as we have browser extensions for Chrome and Firefox. So it's a little more limited, of course, to trigger some profiles on a post request is not going to be as flexible as using the CLI. But yeah, it's just browsing, click, 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 profile, and bam, you get the results. In terms of confidentiality, privacy, and GDPR, what's really important is that Blackfire does not collect any source code, and it does not collect any end user data. When I explained that the probe will send data to the agent, there's a really important step here where the agent, when it collects actually all of the function arguments, it's going to anonymize everything. So if you have, for instance, a SQL query that is going to catch an end user email address, this is going to be fully anonymized before it is sent to our servers. I strongly encourage you to have a look at the documentation that I'm pointing here on the slide. So take a moment to flash the QR code if you will. This also leads to a paragraph where we release the PHP script so that you can actually have a precise look at what we do send from your servers to ours. So you just don't have to take my word for it. You can actually verify it on your own. So we don't collect any end user data and we don't collect any source code. The only data that is sent to our servers is basically function names, the relationship between, well, this function called that one, and the performance metrics. That's it, nothing else. There is still, of course, a couple of use cases where it makes a lot of sense that we disable the anonymization. So for instance, if you're actually working on some specific use cases around SQL queries, it might be very interesting actually to have the parameters of the SQL queries that are displayed, which we normally, again, just simply remove even before it is sent to our servers. So this is why we developed a special feature. We call it the Debug add-on that enables to disable the anonymization. It is really done ad hoc. So it's just for given requests where you will say, okay, for this one time, I want to disable the anonymization, which avoids, of course, again, to have, unfortunately, inadvertently, some end user data that will be sent to our servers. At the same time, this feature also disables the pruning. So let me actually go back to this slide here. Another really important thing that the agent does is that whenever the probe is collecting data, it may actually collect a tremendous amount of data. And it can therefore also collect some data that are not necessarily useful when it comes to performance optimizations. So what the agent does is that in order to reduce the payload that is sent to our servers, as well as to enable to have a simpler whole graph view like the one here on the left-hand side, in order to have a simpler view here, we simply remove all of the function calls from the payload, all of the function calls that are responsible for less than 1% of the overall resources consumption, because those calls are going to be insignificant. They're not going to be useful for you to optimize the performance of your application. By doing that, again, we reduce the amount of data, we reduce the noise on the call graph. Now, in that debug situation, removing those calls sometimes can be a pain for you because, hey, it could be that we just removed the one call you were looking for to debug. So again, in that situation, there is the possibility to disable what we call the pruning, so the removing of lesser significant calls. Last but not least, so all of this is based on special headers. So when you do a Blackfire curl, or when you click on the button of the Chrome or the Firefox extension, what happens is that it's just regenerating the HTTP request. So for instance, if we click on the browser extension, it's going to generate a new HTTP GET request, except that with this GET request, there will be a special Blackfire header that will be added. And this is the signal for the probe to start collecting the data. So again, this is the reason why an end user is not going to be impacted by the Blackfire instrumentation and overhead, because that end user is not going to generate a Blackfire header. And if somebody is playing around with the headers sent to your site, they will anyhow not have the right cryptographic signature so that they can actually generate a profile. But that's a very important thing. If you want to profile your code with Blackfire, you must, of course, let those requests reach out to the correct server. So if you have any load balancer, cache, CDN, reverse proxy, you must make sure that those requests reach the server where you have Blackfire installed. The typical error message is going to be that one on the screen here. Are you authorized to profile this page? Probe not found, invalid signature. We actually don't want to make that error message more specific. We don't want to tell you it's the wrong credentials, because actually this would be less secure than telling people, hey, we didn't even detect Blackfire. So, it could be that somebody is just playing around trying to figure out, hey, do they have Blackfire installed? Can I maybe try to do something about it? Well, if they don't have the right signature, we're not even going to tell them that Blackfire is installed. Yeah, so that's essentially what I wanted to introduce to you today. Again, feel free to contact us on our booth, over Twitter, over our support site. And if some of you have questions now, I'll be happy to answer.